does. Don't you notice it switched? In polar, just going back and reviewing a few things before progressing onward. With r and theta, who is my dependent? R. Who is my independent? Theta. And that leads us to, okay, so we're going to be given functions of thetas, functions in terms of thetas, and so then when we're taking a derivative, it's going to be y prime of theta over x prime of theta. You guys said we already had this one written down, right? Problem, do we already have this written down? In a way. How do you see we already have this written in a way? How can this be rewritten? It could be r sine theta being derived over r cosine theta. And didn't we talk about, isn't there a card of relationships of polar curves where y is equal to r sine theta and x is equal to r cosine theta? Okay. You're going to see some other stuff kind of like that as we go. You can technically memorize that if you would like. Sometimes it'll come in handy and sometimes it's trivial. But anyway, I just wanted to show that to you because yesterday we're like, oh, psh, that's the Endeavor card, no big deal. But it's technically not. It's technically a combination of the two forever cards. Okay, we talked about yesterday how you can get roses with lots of different petals. How many petals are there from the 6 theta? 12. Even numbers are doubled, odds stay the same. Okay, so there are 12 petals. Here's something interesting just really quickly with roses. Remember how I had that big old page of all the different shapes? Can I have you guys look at the roses based on sine and cosine and try to figure out how we can, from a picture, figure out whether it was a sine curve or whether it was a cosine curve? Where are my pictures? Oh, there they are. Okay, look at the roses based on sine. Look at the roses based on cosine. What do you notice? If it has sine, what kind of symmetry does it have? It might not. It might not touch the x-axis, but it has y-axis. It's not called y-axis anymore. Pi over 2 symmetry. Theta equals pi over 2. Oh, you're thinking inverse. When you're thinking not an inverse. Yes, an inverse.
Where it has symmetry over the diagonal.
Yeah, inverse. I'm right. Why am I second guessing myself? Inverse has symmetry like e to the x, ln of x, and e to the x. It's across the y equals x line. But this does not, because look, if you were to do the y equals x line, I mean, if you were to draw some sort of line, maybe, I'm not totally sure it's y equals x, though. It would, first of all, it wouldn't be y equals x. It would be the pi over 4 line, right? And then let's think about sine of pi over 4. Would sine of one side of pi over 4, sine of the other pi over 4. I wouldn't necessarily stress about that. I think it might be possible, and you can see it in both of these. I don't think I would stress about that. Instead, what I would rather you guys hold on to, because I see pi over 4s in kind of all of them right now from looking at it, so I don't know if that would be helpful. But what I do see the difference between sine and cosine, the sine ones have pi over 2 symmetry, which means, oh, does that make sense? Sine in the first quadrant is the same as sine in the second quadrant? Yeah, because sine goes through all the positive values to 1 and then back down through all the positive values to 0. Sine is the same thing in the first and second quadrant, aka turn off your phone. Coming back over here, also has pi over 2 symmetry. Now, I'm not saying sine can never have any other symmetry. I'm just saying sine will always have pi over 2 symmetry. Cosine will always have pi symmetry, 0 symmetry. This would technically be called the polar axis symmetry. We'll talk more about that in a little bit. But polar axis symmetry. Cosine has symmetry this way because cosine is the same in the first and fourth quadrant. Cosine is the same in the first and fourth quadrant. Not to say it can't have other symmetry, but cosine always has polar axis. Sine always has pi over 2 symmetry. Coming back. Okay. Talked about limacons, talked about how they're going to double in on themselves if the radius can be negative, which we'll figure out by this leading coefficient being higher than this, so that when cosine is 1 or negative 1, as long as the r's go negative, there will be an inner loop. Hey, there's a cosine. What kind of symmetry does it have? Polar axis. The limason is going to be this away if there's a cosine. The limason is going to be this away if it's a sine. Interesting. Over here, ooh, what kind of symmetry does it have? The pi over 2, because it's a sine curve. Are we seeing? So the circle won't be here. That would be a cosine. The circle will be interesting. Okay, let's go down to example number 2. Okay, find the slope of the rose curve. Ooh, they told us it was a rose. How many petals? 3. Good. The slope of the rose curve, 2 sine of 3 theta, at the point where theta equals pi over 6, and use it to find the equation of the tangent line. Okay. It didn't ask us for a graph. We'll look at a graph in a second, just for sake of having that visual in case it ever came in handy. How do we find the slope of the rose curve at pi over 6? Derive it. So, dy dx is equal to, wait a minute. How do I do y prime over x prime? Yeah, but how do I get that? There's no y equals and there's no x equals. Are we seeing something cool, kids? Are polar derivatives going to be as easy as parametric? No. Parametric, it's x equals y equals. Here you go. R is given as a function of theta, and then we have to find our own y and our own x, because polar graphing does not work with y's and x's. So we have to make it happen ourselves. We have to make it happen ourselves. We have to make our x, we have to make our y. So could you memorize up above if you're doing polar area and you have r? Fine. R cosine theta, r sine theta is going to be the derivative of? It's not going to be d dx though, right? Do you see why the formula up above put it this way? So if you had y of theta, x of theta, then yeah, I guess we could just take derivatives. But are you going to be given that with polar curves? Probably not. So some of you might want to go back to your endeavor cards and you might be like, you know what, I'm not sure I'm going to remember that, so I think I might write down the whole, take the derivative of r sine theta, take the derivative of r cosine theta. That might be helpful for some of you to actually write down and memorize. Why am I giving you options? You're about to be in college and no one's going to say this is how you study. Okay. Anybody doing product rules? You guys do you and me do me, because when I do you, it doesn't always work out well. Shh. You do you. Second, shh. You do you quietly. Okay, we're just taking derivatives, right? Derivative of the y expression, derivative of the x expression using the product rule. Options. Do we have to simplify first? Could we just plug in first? Okay, just saying it's an option. Not saying you have to do it one way or the other. Could a couple of you? Never mind. Never mind. I was going to say we could use maybe the double angle property, but I had plugged in my pi over 6 wrong because it was supposed to be 3 pi over 6. So that would need to be pi over 2 cosine of pi over 6. Yeah. Well, but the problem is one's a sine, one's a cosine. They don't match. So I can't factor out. Yeah, I wish we could. I mean, we can pull out 2. I mean, we could pull out 2, but I don't know if it's going to help a lot. But yeah, we could. I mean, at this point, I'm kind of like, anything I do, I'm going to have to rewrite the whole string again. It's just going to take time. You see what I mean? So I'm not saying it's bad. We definitely could. I am going ahead and plugging in theta equals pi over 6. You guys double checked, or has anyone double checked? We can just keep going. Cosine of pi over 2 is going to end up being 0. Yeah, kid. You guys keep doing your process. Don't just take mine. And as you do, I'm going to go ahead and open up my calculator just to show that if it was a calculator allowed problem, which I doubt it was, but if it was, just making sure in polar mode that we know how to take derivatives. Uh-oh. This isn't one of your guys', is it? It'll be here. It'll be here. I usually can keep tabs on things. You guys want to take a quick peek at the picture up here? Why does it make sense it has 3 petals?
Because it's a sine theta.
Why does it make sense that it has pi over 2 symmetry?
Because it's sine.
Why does it make sense that the radius needs to go out to 2?
Because it's 1 by 2.
So the highest sign can be as 1, right? So the maximum radius is 2. Because remember how this screen is technically, like, actually if we were to measure it with a ruler, is shorter than that screen. So this is a bit distorted. If we were to do zoom square, it might help just a little bit, but it might cut off a few things. It makes it a little bit better. I'm not sure if it makes it tons better, but a little bit better. And also, I don't know, I think it's like an optical illusion in the sense of whenever things are diagonal, it's going to look a little differently than if it's straight down, because you can't see the full linearization. It could be a programming thing too, but that looks pretty even, I think. Yeah. Question, how do we use the whole second trace thing? What am I solving for right now? Yeah, I'm solving for the slope of the tangent line, right? Does it make sense they might ask us for dr theta? Yeah, they might. They might ask us for r prime in a different example, but right now slope of the tangent line, I need number 2. And I'm trying to find it at, ooh, I just hit enter and I didn't mean to, I apologize. At pi over 6. If you're in radian mode, pi over 6 should work well. Does it work well? Yeah, if you were to do the square root of 3, it's 1.732051. So if I was to graph this tangent line, it would be sloped down that amount, which would be about down 1-ish, 2-ish, and then over 1-ish. Does that make sense, guys? Okay, do you see how that's also along the pi over 6 line? Okay. Ooh, gracias, I didn't keep reading. What did I not? I didn't go back up to read it. Okay, how do I find the equation of the tangent line at pi over 6? Oh, this is so easy, right? Calc AB, we like Calc AB. It's y minus y1 equals m. We already know that. Negative root 3 times x minus x1. Okay, so what do we plug in?
Well, n is negative square root. Oh,
But it's easy, right? Because they give us pi over 6, and that's always in the x spot, and then we just plug in for the, wait,
no, that's
this is theta. I need to find x, because don't I need to find what x of pi over 6 is?
oh, plug it into what you solved in the first equation.
Exactly. Which is r. Wait, who was r?
R was 2 sine 3.
So 2 sine of 3 theta is pi over 2, because 3 times pi over 6 is pi over 2. So that's my r, but I also need times cosine of theta. And then I can also do my r times sine of theta, right? That was pi over 2, because it's 3 pi over 6. Struggle. Sine of pi over 2 is 1 in both, right? So for my x of pi over 6, I end up with 2 root 3 over 2. And then for my, because cosine of is root 3 over 2. And then for my y, I'd have 1/2. So I'd have 2 times 1/2, which would be 2 over 2. Could you simplify it? Yes, of course. Could you leave it and stick it to the man? Yes, of course. All right. Are we seeing some things in polar that we might have to think a little bit additional or a little bit beyond what we've done before? But are the basics still the same? Yeah. Just have to realize when they give us theta, are they giving us x? No. Are they giving us an independent? Yes. But is it x? No. X and y are separate from r's and thetas. Okay. Ooh. A few pre-calish things, just to break it up. A few pre-calish things. How do we convert x squared plus y squared equals 25 to polar form? I mean, it is a basic graph you should know. It's a circle with a radius of 5. Now, if you weren't quite sure about that, don't we technically have in our Endeavor cards from the beginning of the year relationships between x and y and r and theta? So what would x squared plus y squared equal? So, is this the only polar equation? Couldn't r be plus or minus 5? R could be plus or minus 5, technically, right? Because I would plug back in x squared plus y squared for r squared, so I could rewrite it as r squared equals 25, but I could solve for r and it's plus or minus 5. Okay, how about number 4? Any ideas? Well, isn't y equals 1 an equation or x equals 5 an equation? R equals 5 is an equation too. Because think, if I start doing 5 times sine of theta, that 5 will sometimes get cut down by the 1/2s and the root 3 over 2s and root 2 over 2s. I need that 5 to be constant. So if you guys were to go back, or if we were to go forward to that page of graphs, there are circles sometimes, but the circles show up when r equals either constant times cosines or sines, but look and check out those circles. Are those centered at 0, 0? No. To get a circle centered at 0, 0, it's just going to be r equals the 5 line, or r equals the 2 line, or r equals the 7 line. Does that make sense? Okay. So then coming on back, how do we convert if we have r equals 3 secant theta? Who's secant? Or it's hypotenuse over adjacent. Sha, cho sha kao. Sha, hypotenuse over adjacent. Isn't secant just r over x? So couldn't I just make this r equals 3 r over x? Then couldn't I multiply by x and divide by r? Oh, that's a vertical line? Yep. Were we able to make it an f of x, y equals? No, because it's a vertical line, but whatever, that's the path. If you were to graph it, it would look like a vertical line. You guys see how this triangle is kind of important when you're converting? We'll say yes. Ooh. Do we know how to do it?
Yes.
The answer is yes. Because wouldn't we take d theta of, which would be r times sine. If some of you didn't automatically jump to y prime, aka r sine theta, I think you need to write it in your endeavor card. Yeah? And then r cosine theta. What am I doing? I'm making my x and I'm making my y so then I can derive.
How do you know that?
Because it's y prime, r sine. See it? Exactly. It's okay, we're getting used to it. There is no y, so we have to make it r sine theta. There is no x, so we have to make it r cosine theta. Yeah? Now, does it make sense? Does it make sense if you can write dy dx as d theta of, such a struggle. I'm showing you this because a few people last year, I forget if it was Georgie or if it was someone else, they actually liked this version better. And here's why they liked it better. You could say dy dx is equal to r prime sine plus r cosine all over r prime cosine minus what's the difference between this and this? This has already been product ruled, but you have to memorize it. This, you remember who y and x are, and then do the product rule the old-fashioned way. Easton, hi. Good morning. So, this way, you remember who y and x is, who they are, and then you derive. This way, you're like, hey, product rule, just plug and check. So, what would be the difference, rather than like having to do product rule here, we could just go straight to, okay, dy dx is equal to, all right, fine, who's r prime? Cosine theta times sine, plus, who's r? All over, who's r prime? Times cosine theta, because you make it squared, right? Minus, who's r? So can you memorize him? Yes. Can you remember it comes from this? Yes. Can you forget that y equals r sine theta and x equals r cosine theta? You can, but you shouldn't. Can you forget the product rule? You can, but you shouldn't. Any way you memorize it. If you memorize it this way, there's the danger that you forget where it's coming from. And if you just go this way, there's the danger that you mess up your product rule. I don't know what's better. It kind of depends on you. Half the class, it was even less than half the class. I think only 2 of them actually would memorize that and use it. The rest of them would just go the old-fashioned way. It's up to you. You can choose which way you like better. But now, what's our job? Plug in 3 pi over 2, right? So when we plug in 3 pi over 2, we can put my little such that, if I can fit it, whoosh, such that theta is equal to 3 pi over 2. 3 pi over 2, hold on, isn't that,
-1 0. 0, -1.
Sorry, I just don't like, it's not you guys, I'm just writing a pair, an order pair, and I don't want you guys to think that it's polar. Does that make sense? Okay, so I could say x is equal to 0, y is equal to -1, and why is that easy? Because I can come up here and say, oh, cool, when I plug in 3 pi over 2, what's all going to be zeros? all of my cosines. So that's going to be 0. That's going to be 0. That's going to be 0. And then what are all my signs going to be? Well, that's 0 anyway. Who cares? And that one's going to be negative 1. I'll still put it.
Wait, but doesn't it?
Just double check the bottom is not 0, right? But then I end up, and if you guys look at that, it is going to end up being negative 1, 1, negative 1. Are we okay? Okay. Well, if it's 0 over 0, it would have been DNE. So I'm just saying, just be careful. So our slope is 0. AKA, there's a critical number. AKA, there's a horizontal tangent line. AKA, there could be a relative max or min if you check it with the second derivative. Just reminding you of CalcBC. Okay. Zoop. Now what? You choose how you want to find dy dx, but you would need to find it some way. Either choose using the product rule already worked out, or you choose you making x and y and then taking the derivative with product rules yourself. Does that make sense? Okay. You choose whether the product rule already worked out, or you choose make the x and y product rule it yourself. Giving you guys a little bit of a head start, but I'm just going to play. But you guys don't need me. You can go ahead and go for it. Keep an eye on the entire set of directions. Is it okay, kid? Would I have a problem if I would have any shared thetas? Would I have a problem if any of these were shared? Because horizontal tangent lines must make the whole thing 0. And if I had a 0 that was top and bottom, wouldn't that be an indeterminate? Right? So just be careful of that. But you guys are double checking my trig, my math. Yeah. It would technically not exist. It wouldn't be vertical or horizontal. If you're thinking about slope fields, for slope fields, when they were doing slopes of horizontal, vertical, a 0 over 0 would always be blank. Because L'Hopital's rule is asking what it's approaching, assuming that there is approach going on, whereas with us, we're asking what's there, and what's there does not exist. Yeah. Back me up, Kyle. Okay. So then all of my horizontal tangents would be all of my verticals. Now, I haven't really seen them, I don't think, ask for the plus 2 pi n's. I think they're usually asking within an interval, so you would just give the appropriate ones in the interval, 0 to 2 pi, negative pi to pi, whatever they're asking for. But does this make sense? Yeah. Yeah.
So wait, does it sine equal 0 at pi over 2?
Oh, thanks. You and I both made the same one. I caught it down here because I almost did it backwards for sine. I just never came back and changed it. Thanks, guys. So it'd be pi over 2 plus pi n. Does it make sense why pi n, though, not 2 pi n? Because isn't cosine 0 at both? And so I could say plus pi n, I get them both. Or I could say pi over 2 plus 2 pi n and 3 pi over 2 plus 2 pi n. I forgot to change that. Now we're good? No, sine is negative 1 only at 3 pi over 2. So I can't have it be at positive 1 because that wouldn't work. Jason? But the problem is if you divide, you lose all those solutions. Does that make sense? That's why factoring is always the safer, better route, because when you divide, it just disappears into nothingness. Whereas there are actual solutions that would have. But good question. Because some of you would think of subtracting and dividing and saying, forget him, but then you forget all of his solutions too. Okay, are we all right? What's the dilemma? Are those my answers? No. What was the question actually asking for? Only one point where both are true. But where's the point where you have 0 over 0? The point exists. The point is there. The slope is, but the point is there. What do you mean? No. Zero's not even an answer. By you guys fixing my mistake, there was a shared value. What's the shared value? When theta equals? No, not pi over 2. 3 pi over 2. Because this one sine needs to be -1. So when does cosine equal 0 and sine equal -1? At theta equals 3 pi over 2. So therefore, I need the point. Ooh, I need r and theta. True? So I know the 3 pi over 2. What's my r going to be? Plug it in, plug it in. Sine is equal to -1. Dun, 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 dun. I should have done like, but I didn't. Struggle, what was the difference? Did it say find all the points of all the horizontal and all the vertical? No, it said find the point that had both. So we were happy to see what was shared. Thank goodness there was one that was shared, or else we'd be kind of up a creek without a paddle and have to say, none, I don't know, I did it wrong. Oops. Maybe like an A. An A or B or C of an F or Q. Probably not a multiple choice. But don't you want that? Because then all of your work is being given points as opposed to a multiple choice where it's like right or wrong. Oh. You guys know vertical and horizontal tangents show up. Okay. Question. What is this whole page talking about? By hand. Woo! Is it easy?
Well, what they gave us was easy.
You could memorize. You could memorize if you really, really want to. I have it in. You could print it out. You could put it in your notes. You could put it in your Endeavor cards. You can memorize. That's totally an option. Have we gotten to polar area? No. Are we going to? No, but we will have gotten all the way up to polar area. What do I need you to do by Monday? Figure out how to graph them. By hand. It's from Calculus Maximus, I think. He likes to be silly. Why? Why have I made it 2 by 2 by 2? Question. If I were to start plugging in stuff, theta is equal to and r is equal to, why am I going to start at 0? So I know that it goes out to here, right? Why am I next going to go to pi over 2? Could I have gone to pi over 6? I could, because it's 1/2. It's a nice one. So then 2 times 1/2 is 1, so that's going to be 1. So I could go ahead and do pi over 6 is going to hit at 1. I could have done that. And then I'm going to go to pi over 2 and say, hey, that's 1, so that'll be 0. Oh, so it does this little thing? Why we got to keep going? Do you think there might be some symmetry? Do you think maybe you'll find some shortcuts? But do you think maybe to some extent you just got to plug in thetas and r's? What I want you to do is get up in homework all the way up until polar area. Don't you dare do any sort of polar area. But do practice polar graphing.